Okay, we're going to be looking at non-equilibrium exam questions. And for our first question, we've got a particle mass 0.8 kilograms is held at rest on a rough plane. And the first important thing to do is make sure you've got a clear diagram. And you've got to put all the forces. This diagram is not included in the question. I've just pre-drawn this. We're told the plane is inclined at 30 degrees. We're told it has a mass of 0.8 kilograms, so therefore the weight will be 0.8 times g. Particles released from rest slides down the greatest slope. The particle moves 2.7 meters in the first 3 seconds. So we're going to have a normal reaction, and we know that it's on a rough plane, so we know that we've got friction acting up the plane. So those are all our forces, and we know that it's going to accelerate down the plane. Moving on, we're going to now look at the model. We're going to resolve all the forces. So first thing we need to do is we need to work out all our angles here. So this is 60 because that is 90, therefore this is 30. And therefore we can resolve this force here. Now we're going to be looking at perpendicular to the plane, and we're going to be looking at parallel to the plane, and we're going to assume that this way the acceleration, always go with the where you think the acceleration is being positive. So we have the normal reaction, we have the friction, and we have the 0.8 g, and we have our resultant force. Okay, so we've got R acts completely that way. So we've got none of FR acting perpendicular. And we've got 0.8 g, we've got this bit of 0.8 g, so it's going to be minus 0.8 g cos 30, because that is the component of that section. So if you take that angle, take that side, that's going to be 0.8 g times cos 30. Going parallel, we've got none of R, because none of that acts parallel. We've got minus the friction. We've got 0.8 g, and because it's the opposite side of the 30, it's going to be 0.8 g sine of 30. And because the acceleration's this way, we're going to have a resultant equal to ma. Okay, and the resultant perpendicular is 0. Otherwise, it would be leaving the plane, the contact of the plane. It would be flying or it would be going into the ground. And so that's our model. Now, from our model, we are going to set up our equations. But let's first of all look at the question. Okay, the particle moves 2.7 meters, so we know that s equals 2.7, and we know that time is equal to 3 seconds, and we know that u is equal to 0. So we can use s equals ut plus a half at squared to find out the acceleration. So 2.7 will equal 0, because you've got to use 0, plus at, so it's plus a half at squared. I missed out the half. So you get 0.5 times a times 3 squared. So a comes out to be 0.6 meters per second squared from that. So we've answered part A. So from this, we can set up our equations. So we know that R minus 0.8 g cos 30 will equal the resultant in that direction, which is 0. So that's going perpendicular. Going parallel, we know that 0.8 g sine 30 minus fr will equal ma. And we know that m is 0.8 and we know a is 0.6. So we can put that all in that equation. So from the equation 1, so 1 will imply that R will equal 0.8 g is 9.8 times by cos 30. So we're going to get 4g root 3 over 10. Now the friction is equal to mu R. So we know that mu it'll be equal to mu times 4 root 3 g over 10, because friction equals mu R. Now we can put this into our second equation here. Okay, we can put this into our second equation. So substituting that in, we get 0.8 g sine 30, which is a half minus the friction, will equal 8/10 of A, so that's going to be 48 over 100 or 0.48, depending on how you look at it. And we know that the friction is equal to this. So we can put, we've got 0.4 G minus mu times 4 root 3 G over 10 equals 0.48. And if we take this to this side, take that away from that side, and divide by this, we get our answer. So working that all out, we get mu is equal to 0.51. And that is our coefficient of friction. So remember, draw a diagram, set up your model, write out your equations, substitute in, and get your answer.